It's time for another amazing chemistry video with Mr. Stapleton. Proudly sponsored by Farming Green Nice Coffee.
Okay, so in this video, what I'm going to be doing is starting to apply the principles of collision theory, which hopefully you've learned from the last video, and apply them to some practical examples, because I love putting extended response questions in around this. If not, they'll at least build in a question with a couple of parts to test your understanding about knowing that how particles collide with the correct orientation and minimum energy in order for a reaction to occur. Okay, so make sure you can do those energy profile and energy distribution graphs that we looked at in the last video, because we're going to use them today. So anytime you're wanting to explain an answer when it's asked you to use or reference to the collision theory, there's basically three things that you want to address, okay, if they're relevant. First one is about the energy of the particles. Okay, so you want to talk about whether the energy of the particles is increasing or decreasing. Okay, you want to talk about the orientation of the particles. All right, so whatever you're using aligning up the particles in the correct way to allow the reaction to occur faster. Okay, and then you want to talk about the frequency of the collisions. Okay, and then you're going to be using your energy profile and energy distribution graphs that I showed in the last video in order to explain it. So first one I'm going to use is I'm just going to look at the effect of temperature. Okay, so one of the things that can impact on the rate of a reaction is temperature. Okay, so I'm going to talk about temperature, and I'm going to talk about it in the context of a fridge. Okay, so we have food that we put in the fridge, okay, and we do that to slow down the decomposition of the food. You know, if you leave meat out on a bench, for example, some raw meat, it'll go off very quickly, all right? Whereas if you put it in the fridge, it will last a lot longer. You put it in a freezer and it can last up to 3 to 6 months, okay? So we're going to talk about, in terms of collision theory, why that occurs. So first of all, what we need to get back to is our energy distribution graph. Okay, so our energy distribution graph looked like this. Okay, so we had number of particles along here, all right, and we had energy along here, and we have our bell curve distribution of our particles. Okay, and we've got our activation energy, which sits around about here. Okay, so with temperature, there's a couple of things you need to know. First of all, when we're talking about temperature, there is no effect, all right, no change to the activation energy. Okay, so we're not changing the minimum energy required for the reaction to occur. Okay, what we are going to be affecting though is the energy of the particles. So because we're talking about a decrease in temperature, okay, temperature is a form of energy, all right? Heat's a form of energy. So when you're decreasing the temperature, you are decreasing the energy, okay, of the particles. So what that does is that has a direct flow on effect to our energy distribution graph. So instead of having this nice bell curve distribution that we've got, all right, the particles have less energy. So imagine it's like they're colder, they try to huddle up a little bit more. So our bell curve distribution actually condenses or shrinks down, okay? So what we end up with is something that looks like this now. I'm going to use blue because blue's for colder, all right? So our particles, now we get more of them with a lower energy, okay, like this. And so that means now, instead of having all of this section over here, all we've got is this tiny little section here. All of these are the particles that have the activation energy required. So it's only those particles which are going to actually have the energy required to be able to react. Okay, so already you can see the impact on the energy. Particles have less energy, so we've got less particles that are going to actually be able to collide. Now the other thing that's going to happen, all right, is if we have decreased energy of the particles, what that means is that the particles are going to move slower. Okay, it's colder, less energy, got less kinetic energy, so they're not zipping around as fast as they were before. So if they move slower, what that's going to mean is we're going to have less frequent collisions. Okay, now temperature doesn't affect orientation at all of the particles, that's why I've skipped that one, but I've talked about the energy of the particles. All right, we've got less energy, we've shown that in an energy distribution graph. Okay, so now we're going on to talk about the frequency of collisions. So the collisions, we have less frequent collisions when particles move slower. Okay, so not only have we got this effect of less frequent collisions, we've got less particles that have energy greater than or equal to the activation energy. So it's twofold, okay? So there's one, less collisions. All right. When the collision does occur, there are less particles with energy greater than or equal to the activation energy, which is what they require to react. So therefore, overall, we have a decreased or reduced or slower, whichever you want to do, rate of reaction. Okay? So you could explain this in terms of saying decrease in temperature means that particles have lower energy. You can show that in an energy distribution graph. Because they have less energy, they move slower. All right, so because they move slower, there are less frequent collisions. So all in all, what this means is you've got fewer collisions occurring. Now I should put in that special term that I've told you to use before, per unit time, okay? And there are less particles with energy greater than or equal to the activation energy. So overall, we have a decreased rate of reaction due to a decreased frequency of successful collisions per unit time. Okay, so that's an explanation of why a decrease in temperature affects our rate of a reaction. Obviously, if you're going to turn around and talk about an increase in temperature, it's the opposite. Increase in temperature, more energy, particles move faster, more collisions, more particles have energy greater than the activation energy. Okay. The general rule of thumb when we're talking about temperature is that a 10-degree rise equals 2 times the rate. Okay, and it kind of goes backwards as well. So if you decrease it by 10 degrees, okay, you are halving the rate at which it will decompose. So if you go from 21 degrees at room temperature down to 1 degree in a freezer, what you're actually doing is you're reducing it by a factor of 4 times, okay, in terms of putting the meat into the freezer. So that's one about temperature. I'm going to look at a couple of others now.